Good morning, chemistry students. We are experiencing some odd situations here going on. We have switched to e-learning for this week. Hopefully you got the message about that. And so our class times are going to be a little bit different, just like they were earlier in the year when we were on e-learning. So we will be starting class later, and the class period will be shorter. So that will go through December 3rd at least. So here we go. Today we're going to be taking some notes on bonding, so hopefully you've got some paper and something to write with, and you're ready to write some stuff down. I encourage you to pause as you go through the video and write things down, and I'll try to indicate which things are most important for later on as I go through. So bonds, chemical bonds, are intramolecular forces. Intramolecular, intra means within, inter means between. So intramolecular forces act between atoms within a molecule. And there are several types of bonds, but the two most common are called ionic and covalent. And you should remember that atoms seem to prefer having a certain number of valence electrons around them. And that number, of course, is 8 valence electrons. Remember, atoms tend to try to be similar to noble gases. And noble gases, with the exception of helium, of course, all have 8 valence electrons. And why do they do that? Because it makes them stable. Why do electrons want to be in groups of 8? We don't really know, but that's what they do. So that's okay. Ionic bonding involves the transfer of valence electrons. So one atom will have a valence electron it kind of doesn't want, and it will give up that electron, and another atom will accept that electron. Or sometimes an atom will have 2 or 3 or 4 electrons that it wants to give up, and another atom will be able to take those. Or sometimes more than one atom will take those. So here's a little example of how we would make a compound. This is an ionic compound, sodium fluoride. Sodium has 11 electrons. So here it is, of course, energy level 1, close to the nucleus, has 2 electrons. That's all it can hold. Energy level 2 has 8. Now we're up to 10. And energy level 3 has the 11th electron. Lonely valence electron. How sad. And fluorine has 2 electrons, 9 electrons total, of course, because it's element number 9. And it's going to have 2 electrons in the first energy level and 7 in the outer energy level. 7, but it wants 8. So it's got room for an extra valence electron. So when these two atoms get together, an electron is transferred from sodium to fluorine. And now that energy level is no longer the outermost energy level for sodium, so it now has 8 valence electrons. When atoms lose or gain electrons, what happens? Well, they get a charge, of course. If they lose an electron, the charge is positive. If they gain an electron, the charge is negative. And this would be something that you'd want to write down if you didn't already know this. Hopefully you remember this from before. So now we have sodium with its lost an electron, so it gets a +1 charge. And fluorine has gained an electron, so it's going to get a -1 charge. So there they are, a +1 and a -1, and they're attracted to each other. Opposites attract in chemistry. Opposite charges always attract in chemistry. And since they each have 8 valence electrons now, they're stable, they're happy. This is a nice stable situation. In fact, this compound is so stable, it's really hard to break apart. And we thought it was an element for a long time until the 17 or 1800s when we developed electricity and were able to separate these two. So as you should remember, atoms with opposite charges will be attracted to each other. Covalent bonding. Covalent bonding involves the sharing of valence electrons. So you should write that down. Ionic bonding involves transfer of electrons. Covalent bonding involves sharing of electrons. And it's always the valence electrons that we're concerned about here. So pause and write that down. So atoms can share electrons in order to have that magic number of valence electrons around them, which again is 8. Compounds formed from a metal and a nonmetal are called ionic. So this is something you definitely need to write down. So your ionic compounds, so again, compounds formed from a metal and a nonmetal are called ionic. You should write that down. Compounds made from two nonmetals are called molecular or covalent. They're going to have covalent bonds. So you should write that down. So I'll pause for a second so you can do that. So what about compounds formed from two metals? Well, they're not really compounds. It is something that exists. These are called alloys, and they have a special kind of bonding called metallic bonding. And it's a bit unusual, and we'll talk about it later on. Right now, we're most interested in the other two, ionic and covalent bonds. So again, where are the metals and where are the nonmetals? Well, the things in pink here are metals. The things in green here are nonmetals. And if you look, you can see here the staircase. And we will consider that staircase to be a solid, hard line. So everything to the left of it is a metal. Everything to the right is a nonmetal as far as bonding goes. Yes, metalloids exist. That's what those ones that are sort of purple and green together, that's what those are right here. And hydrogen is not really a metalloid. It is a nonmetal. So, but we'll consider those to be, if it's on the left of the line, it's a metal. If it's on the right of the line, it's a nonmetal, period. Okay, there are two types of covalent bonds. So we've got ionic, or metal-nonmetal. Covalent are non-metal-nonmetal. But there's two types. Sometimes the atoms will share their valence electrons in a very equal way. This is called nonpolar covalent bonding. Polar refers to opposites, think North Pole, South Pole. Sometimes atoms will share their valence electrons in an unequal way. This is called polar covalent bonding. And you should pause and write those down. Maybe run it back. We have not learned to name compounds, so we'll skip that slide. Oops. Polarity of bonds. Polarity indicates how much electrons are pulled to one end of the molecule or the other. In nonpolar covalent bonds, two identical atoms are bonded, so they each have equal ability to pull those electrons. Every atom has a different strength at pulling electrons toward itself in a bond. So this would happen in diatomic molecules. All those gen and ene elements that are diatomic, they're going to share their electrons equal because one oxygen atom and another oxygen atom have equal strength at pulling electrons toward themselves. In a polar bond, the electrons are pulled toward one end of the molecule or the other. Ionic molecules are, we could say they're very, very polar. The electrons are completely removed. Remember sodium fluoride. An electron was completely removed from the sodium and given to the fluorine. And so they have one atom that's so strong it can pull the electron away totally from the other atom. So the electrons are pulled to one end of the molecule. Now it's a matter of degrees, and there really isn't a distinct line between polar covalent and ionic molecules, but we do have a cutoff that we use. And so we can do some math and figure it out, but in this class we've decided we're going to not do that this year because we're kind of running out of time, especially with these 40-minute classes. So polarity is important because it tells us about the behavior of a compound. Like, why is water a liquid at room temperature? It's really light. One molecule only weighs 18 atomic mass units. It's really, really light. It should be able to just float around and be a gas all the time, right? But the polarity of the molecule causes those molecules to stick together. And next semester, we'll talk more about that. Oxygen is a gas at room temperature, and it has a mass of 32 because it's O2, right? So 16 and 16, you can look those masses up on your periodic table. So it's heavier than water molecules. One molecule of oxygen is heavier than a molecule of water. So it's kind of surprising that oxygen is a gas and water is not, but it has to do with the polarity of the bonds. Table salt dissolves really easily in water, but it's got a really high melting point. So why is that? Well, the answer is bond polarity. There are several ways that we can represent bonding so that we have a visual picture of what molecules look like. The most common that we've talked about a little bit before is the Lewis structure or the Lewis dot diagram or an electron dot diagram. It all means the same thing. So to do electron dot diagrams, which was our goal for today, the first thing you need to think about is valence electrons. You need to be able to tell how many valence electrons each atom has. And this is a review from the last unit. You should remember this. But these guys all have one valence electron. That is group 1, including hydrogen, all have one valence electron. These guys all have 2. That's group 2. And all of these here in the transition elements, the lanthanides, the actinides, all of these have 2. Whoops, too fast. Boron's family there has 3 valence electrons. Carbon's family has 4. Nitrogen's family has 5. Oxygen's family all have 6 valence electrons. Fluorine's family, the halogens, all have 7. And the noble gases all have 8, except, of course, helium, which is the exception, and it has 2. So here's how you draw Lewis dot diagrams. First of all, you write the symbol of the element. Then you figure out how many valence electrons it has by looking at it on your periodic table. You might want to write these instructions down. So you might need to pause. And then however many valence electrons it has, you're going to draw that many dots around the symbol of the element. Only 1 dot per side unless there's more than 4, and then you pair them up. Maximum of 8 dots because, of course, the maximum number of valence electrons anything has is 8. So here we go. Carbon has 4 valence electrons because it is here in group 14. 4 valence electrons, so we draw 4 dots. 1, 2, 3, 4. And we typically do top, bottom, left, and right. Nitrogen has 5 valence electrons. 1, 2, 3, 4. And now we got to double up, so we'll put 2 together on the top. Or we could put those 2 on the left or the right or the bottom. Doesn't matter. So now we're going to make a compound. So we already talked about how to do elements before. It's pretty simple. But now we're going to make a compound and put those pieces together. So first you need to think about what each of the atoms is going to look like alone. So we'll start with the atoms. Carbon has 4 valence electrons. There they are. Chlorine has 7 each. So we'll put 7 like that. 2 on top, 2 on bottom, 2 on left, and 1 on the right. This chlorine atom's got a slightly different arrangement of electrons. That guy looks like that, and that guy looks like that. So all the chlorine atoms have 7 valence electrons. Now we're going to put them together to make the molecule. So single atoms go in the middle. So we had a carbon and 4 chlorines. So 1 carbon and 4 chlorines means the carbon atom will go in the middle. And then we're going to add all the other atoms around the outside. Molecules are usually symmetrical. And hydrogen can never, ever go in the middle between 2 atoms. Of course, we don't have hydrogen in this one, so that's okay. So here we go. We've got our carbon atom. It's going to go in the middle. So we're going to start pulling chlorine atoms in, and that one's going to go there. And that one's going to go there. And I'm going to pause right here for a second and point something out. If you look at this chlorine atom right now, it's sharing this blue electron and this yellow electron with the carbon. So now this chlorine atom has 8 valence electrons. Only 7 of them actually originally came from it, but it's going to behave as though it's got 8 now, so it feels stable. And over here, this chlorine atom has the same situation. It's got 8 valence electrons. And the carbon currently has 1, 2, 3, 4, 5, 6. These are shared electrons. If you share something, it belongs to both, right? Here comes another chlorine and the other chlorine. And this is kind of messy, but hopefully you can see each chlorine atom now has 8 valence electrons, and the carbon atom also has 8 valence electrons. 4 that came from it originally, plus 4 more. There is a slightly easier way to do this. So the easier way to figure out a Lewis dot diagram involves a little bit of math. It's not difficult math, though. And I think it's pretty helpful. So the first thing you do is you figure out the total valence electrons for your compound. So you're going to say, all right, CCl4 has 1 carbon, that's 4 valence electrons. And it's got 4 chlorines, They each have 7 valence electrons. So 7 times 4 is 28, and then you're going to add those together. So 4 plus 28 is 32. So we need 32 dots in our electron dot diagram. So we put the single atom in the center, that's carbon. Then we put all the other atoms around symmetrically, and you give each terminal atom, terminal is on the outside, on the outer ends, give each terminal atom the number of electrons it needs. Almost everybody needs 8 valence electrons. The one big exception is hydrogen. Hydrogen needs 2 valence electrons. It does not want more than that. Of course, we don't have hydrogen in this molecule anyway, so maybe that doesn't matter. Atoms can form single, double, or triple bonds with other atoms. So one example would be carbon dioxide. Let's see if I can draw this here, because I don't think, yeah, okay. Let's try this. So we're going to have carbon dioxide. So our total valence electrons will be 4 for the carbon. Of course, dioxide means 2 oxygens. And each oxygen has 6 valence electrons. So I need 16 dots. So here's what I'm going to do. I'm going to start with, I want the pen, but I don't want that color. Start with yellow. Okay. So I'll start with carbon in the middle. And whoops, that's a C. And oxygen on either side, because we want the molecule to be symmetrical. Normally, if it's a single atom, it goes in the middle and the other atoms go on the outside. And then I'm going to draw 16 dots. And the rule was start with your terminal atoms. So 1, let's make that dot a little bigger. 2, 3, 4, 5, 6, 7, 8. And those 2 right there are going to be shared between the oxygen and the carbon. So that oxygen has the 8 that it needs. We only have 16 that we can use, though. So there's 8, 9, 10, 11, 12, 13, 14, 15, 16. So that looks pretty good. The oxygens are happy. They each have 8 valence electrons. However, carbon does not have an octet. Carbon wants 8 valence electrons too. And right now, it's only got these 4 right here. Whoops. Nope. Didn't want to draw that circle. Let's draw that in red. How about that? So carbon only has these 4 valence electrons, and so it is not happy. So what we're going to do is we're going to move a couple of electrons around. So I'm going to take these 2 electrons. Whoops. You're supposed to be erasing now. Eraser. There we go. I'm going to take this one and this one and get rid of them. And no, we still have to have 16 electrons, so I'm not getting rid of them. I'm just moving them. So I'm going to move them to in between the oxygen and carbon. So whoops. My mouse is kind of a pain. Let's see here. Try that again. There we go. So now this oxygen still has its 8 valence electrons, but it's sharing more with carbon than it did before. Carbon now has 6 valence electrons. Of course, that's not what it wants. It wants 8. So I'm going to move 2 more electrons off of this oxygen. So I took these 2 off the bottom. And I've lost my mouse. Where'd you go? There you are. So I erased those 2, and now I'm going to draw them in the middle here. And now this oxygen has 8 valence electrons, and carbon also has 8. So that is what we call a double bond. And that's it for today. You're going to watch the next little video clip to see how to do today's assignment. Okay, now we're going to do the homework worksheet to practice a little bit with bonding and make sure we remember what we learned. So the first thing you're going to do when you click on the link to the worksheet is you're going to log in. So you should already have a login. We've done this before. Let's see here. my info. Let's see here. Okay, the next thing you're going to do is make a copy of the sheet. So you're logged in, you're going to make a copy. So I'll create the copy there. And now I have all of these icons up here that I can use to annotate this document however I wish. So the first thing I'm going to do is get to typing, put my name here. Then I might want to change that text color because it's easier to see if we change it. That'll work. Okay, so the next thing we want to do, now I've lost some instructions on this worksheet. I'll probably update this for you here in a bit. When you click on one of these icons, it gives you the chance to put letters or whatever, typing wherever you want. If you want to go back to where you can just click on stuff, you can go to the pointer and then you can click on things and not have anything weird pop up. So the instructions on this part are supposed to be how many valence electrons are there for each of these elements. So you're going to look those up on the periodic table. Carbon, for example, has 4 valence electrons. Let's see, oxygen has 6. I'm looking them up on the periodic table based on those trends. Hydrogen has 1. And that's enough of me doing your homework for you, so we'll stop there. So you're going to answer those questions, and then you're going to come down here to the part about bonding. And the instructions here tell you again, which you already know, that any 2 metal atoms bonding together make a metallic bond. When a metal bonds to a nonmetal, that makes an ionic bond. And when 2 nonmetals bond, that's a covalent bond. But there are 2 types of covalent bonds. If they are not the same element, it's a polar covalent bond. If they are the same element, then it's a nonpolar covalent bond. Okay, so the bond between 2 hydrogen atoms in H2, get my text tool here. That bond is going to be nonpolar covalent. And between H and O in water, let's see, that is hydrogen is a nonmetal, oxygen is a nonmetal, but they don't match. So that's going to be polar covalent. Polar covalent. All right, so that's that section. I'm going to hit this so I can scroll. Then down here's the fun part. We're going to draw some Lewis dot diagrams. So again, we're going to write valence electrons. That's what VE stands for. And then we're going to do the drawing over here. So for carbon, we have 4 valence electrons. And my drawing is going to look like a C with 4 dots around it. And I kind of want that carbon to be bigger, so I'm going to go up here to my font size, and let's go a little bit bigger. And then I can move it around by clicking here. Okay, so that's good. Now I need to draw some dots. So here I've got circles. I think I want them filled in. So we'll do blue circles. 4 of those. And remember, it's top, bottom, left, and right. Okay, there's 1, 2, 3. It's sort of a circle. They should all be the same size, but I don't like that position. I'm going to move that in a bit. Okay, so there I've got my 4 dots. That's my carbon atom. I like it. I think we'll move on. Let's move over and do sulfur here. Sulfur is going to be 6 valence electrons. I just had to check my periodic table there. I'm going to have an S. Oops, that's not an S. An S in the middle, and then 6 dots around the outside. So 6 dots mean I'm going to have 4 on top, bottom, left, and right, and then 2 extras, and they typically will go apart from each other. 1, 2, 3, I'm running out of time, 4, 5, 6. And there, well, I ran out of time just a bit there, but here we go. I've got my 6 valence electrons for sulfur, and that is my Lewis dot diagram. And so once you fill out the entire worksheet, let's do one more down here. Let's do HCl for fun. Here we've got a molecule. So it's only 2 elements, hydrogen and chlorine. So which one you put first doesn't matter so much. But let's first do the valence electrons. Hydrogen has 1 valence electron, and chlorine's a halogen, so it has 7, so that's a total of 8. And we're going to have an H over here, and then I'm going to leave some space and put a Cl. And then we need to draw in our 8 valence electrons. Now, if you recall, hydrogen only wants 2, so that's kind of a pain. I'm going to go ahead and draw my chlorine valence electrons in. 1, 2, 3, 4, 5, 6, 7, 8. So then I'm going to say, all right, well, how many does each element have at this point? And actually, if we move this hydrogen a little closer, it can share those valence electrons that it's got, shared with chlorine. Let's move chlorine back a bit. There we go. So this is what that would actually look like. And if you wanted to, you could draw some little circles. You don't have to, but let me see here if I can do my freehand drawing. No, I don't want to highlight. I don't want to add text. I don't want to add a rectangle. Well, yeah, let's add rectangles. That'll be all right. And I don't want that color. Let's do green. Okay. So now we have hydrogen. Right. I don't want to fill color. There we go. Our hydrogen, come on now. Save, okay. Our hydrogen has those 2 valence electrons. Remember, that's what hydrogen wants, is 2 valence electrons. And our chlorine here has the 8 valence electrons that it wants, and so everybody's happy. You don't need to draw those boxes, but if you like to, some people feel more comfortable knowing for sure that they've got the electrons where they should be. So you can do that if you like. The last thing I'm going to do here is I'm going to go in the upper right-hand corner when I've got my document finished, and I'm going to go to download/export, and I'm going to download a copy to my computer. And there it is. And then I'm going to, actually that just pulled up a PDF of it, so now I got to save it to my computer. So I'm going to hit download. Yep, that's where I want to put it. And then I'm going to go to Schoology and upload the completed worksheet. So this is just like the other times we've used this website. Hopefully it'll work for you, but if you have any questions, just let me know.